Height above ground, h meters, of a passenger on a roller coaster can be modeled by this differential equation. T is the time in seconds from the start of the ride. And then we're given that the passenger is 5 meters above the ground at the start of the ride, so T is 0, gives h equals 5. And we have to find h. So this is a differential equation, except we've got functions of h and t on the right-hand side, so we need to use separation of variables. You can't just integrate this directly in terms of t, because h is a function of t, but you don't know what it is. Therefore, we're going to first up divide through by h. Both sides, it's gone from the left. Two different approaches from here. You can either consider integrating both sides with respect to t, and then use the chain rule to say, you know what, this is simply dh. Or you might be somebody who's learned to times through by dt, and then integrate both sides. I always say in my videos, like, I'm not a fan of this method because you're timesing by infinitesimals without really showing why you can do it. Whereas in the first method, I'm just, you can actually prove this without too much difficulty using the chain rule that this is true. But they get us to the same place, okay? That's the main thing. So let's integrate. I'm going to get ln modulus of h when I integrate 1 over h with respect to h. And then on the right-hand side, cos integrates to sine. It's going to stay as sine, but it's going to be 0.25t inside. But if I differentiate that back, I would times by 0.25 or a quarter. So when I'm integrating, I need to divide by it. I'm going to divide by a quarter or times by 4. The 1 over 40 sort of passes through. I'm going to get 4 over 40 or 1 over 10. Always worth just checking. If you differentiate that back, the sine will become cos. We'll then times by the derivative of the inside. That's just a quarter. The quarter times 1 over 10 will give us 1 over 40. And then we put the plus c in. We don't need a plus c on the left because we just need a single constant on one side. Because if you had two of them, you could just combine them together. Up to you now whether you substitute your condition in, t equals 0, h equals 5, or do a little bit of groundwork first. I'm actually going to go for it both ways, I think. So first up, let's do the substitution. So ln 5 is going to equal, well, sine of 0 is just 0. So actually c is just ln 5. Therefore, I get ln h is equal to 1 over 10 sine 0.25t plus ln 5. I could even then minus the ln 5 and get ln h over 5 if I wanted to. Now I'm ready to undo the logs. There's technically still a modulus here. Undo the logs, I can get rid of the modulus now. H over 5 is going to equal e to the 1 over 10 sine 0.25t. H equals 5, e to the 0.1. I'll write that 1 over 10 as 0.1 sine 0.25t, which is exactly what we were required to find. Method 2, I'm going to undo the logs first. So I'll get h equals e to the, I'm right, 0.1 sine 0.25t and then plus c. Now, before I substitute in this scenario, it's good to actually rewrite it as e to the c. I'm just timesing them together now because that's what happens when you have powers. X to the a plus b. It's actually x to the a times x to the b. I'm using that kind of idea. And I'm just going to give this a new name. I'm going to call it k. So I've got k e to the 0.1 sine 0.25t. So then 5 is going to equal k e to the 0, which is just 1, and I've got k as 5. And from that, I'll get exactly the same answer. So two different approaches. a couple of different approaches in terms of the integration here, but they all get us to the same place. State now the maximum height of the passenger above the ground. So we're looking for the maximum of this function. Well, you could look back at the derivative, dh by dt, set it equal to 0, and solve for that to find the value of t when there's maximums. It's actually going to be quite a lot. But in our case, we can just look at the function. In fact, sine varies between -1 and 1. So the maximum value is going to be 1. And therefore, the maximum value of the function, this exponential, is going to be 5e to the 0.1. We can't get it any bigger than that, because otherwise we'd be times in by, like say a negative for sine, that would be smaller, or 0.9 for sine would be smaller again. Because remember, as the argument in the exponential increases, the function increases here. So 5e to 0.1, put that in your calculator, and you get 5.53. We could write meters, but you actually get away with not writing that. If you did go back to the dh by dt, you would in fact, h is not going to equal 0, so it'd be the cos that was equal to 0, and you could solve that to get t equals 2 pi, 6 pi, etc. And you could put that back in, like then you'd get sine of pi over 2 when you do a quarter times t, and that would give you 1. You get back to where we had just from part B. Passenger reaches the maximum height for the second time, t seconds after the start of the ride. Find the value of t. So we can see our first maximum is going to be, if we take a look at the sine function, because that's the thing governing these maximums. Okay, well, sine takes a maximum at pi over 2. So it would be 0.25t equals pi over 2, or t equals 4 pi. No, sorry, 2 pi. That is going to be the first maximum, in fact. But we're interested in the second time, so I can just add 2 pi to my pi over 2. It's going to give me 5, wait, 5 pi over 2. Okay, that is this one here. Now I times through by 4, I'm going to get t is equal to 10 pi. It's a modeling question, so that then becomes 31.4 seconds. Again, you could do it from the derivative. I've actually already got the 2 pi here. That would be the maximum. The 6 pi would in fact be the minimum. And then the next one after that, you would add another 4 pi to get 10 pi. But again, you don't need to do anything to do with dh by dt at this point. Because of the nature of our function, it's quite nice to just look at it and the exponential and see that, it must be when sine is 1, and just focus on that. Anyway, those are answers. Well done with this question.